Hi everyone, today we're going to do our notes on 2.7. So it's polynomial and rational inequalities. So what we're really doing with the inequality is it's going to help us see what part of the graph falls below the x-axis or what part falls above the x-axis. So you'll start seeing some words like boundaries. So here's our procedures for solving them. You can express the polynomial, you need to express the polynomial with 0 on one side. So you're going to see a less than sign or a greater than sign. You always want 0 to be on the one side of it. And then you can also see the greater than or equal to and the less than or equal to. You're just going to see some of this kind of writing from me or a less than with an equal to sign after it just because of typing in Google. The next thing you're going to want to do is solve the equation for being equal to 0. And this will give you the boundary points. Now these boundary points, we're going to actually put them on a number line in step 3. On this number line, it's going to tell us, again, what's above the x-axis or below, depending on what inequality they give us. So when we're graphing inequalities on a number line, we want to use an open circle for the less than or the greater than, and you want to use a closed circle for the less than or equal to or the greater than or equal to. So again, this one just looks like a normal point. The closed circle just looks like a normal point on the graph, and the open circle is just a point that's not filled in. So from there, you're going to choose points outside and in between those boundary points. This is kind of like how we were testing the asymptotes the other day. You're going to go to the left of the asymptote and choose a point. You're going to go to the right of the asymptote and choose a point. Well, same idea, same idea, you're just going to be using the points that we find from step 2. You're going to put them into the original function, and then once you've tested them in the original function, you're going to say if it's less than or greater than 0, so that way you can compare it back to how your original setup of the problem was. Then you're going to write the solution set that satisfies the inequality that is on the number line. So you're going to use interval notation for that. So whatever you end up using on your number line itself, you're going to then again write the final solution set using interval notation. So let's kind of go through this first one step by step and see how it's going to work out. So the first thing that we need to do when you see this first equation is it's less than -5. So according to step 1, we need to have one side with 0 on it. So I have to add the 5 over. So now step 1's taken care of with the 5 added over. So I have 3x squared plus 16x plus 5. Then for step 2, I need to go through and solve it for being equal to 0. So in this case, since it's a quadratic, I can just factor it, hopefully. If I can't factor it, we've got so many different methods. We've got the synthetic division and things like that. But for the most part, you'll be able to factor these guys. So you can see it factors to 3x plus 1 and x plus 5 and set it equal to 0 still. So really you're just finding the x-intercepts of the graph. So I find x equals -1/3 and x equals -5. So our boundaries so far that we're finding for the graph overall, we go from -infinity to -5, -5 to -1/3, and -1/3 to infinity. Now notice that I'm using all parentheses, and I'm using all parentheses symbols for all of it, even the -5s, even though it's okay to have -5 in here. According to this sign right here, this less than sign, I can't include it. So you still need to watch the parentheses versus the brackets based on your inequality sign. So in step 3, we just plot those points. So there's one of them on the number line, and then there's the other on the number line. So I have -5 and -1/3, and again, they're open circles because of the less than sign. If it were equal to, then they'd be filled in, but it's not, it's just a less than sign. So now what I need to do is I need to test each individual point, okay? I need to test on the left side of this -5, so plug in -6 to the original function. So when I plug that in, I get the -6 squared, so 36 times 3 plus 16 times -6 plus 5. So I find that whole thing to be 17. So when I put this back into this form, you're always, when you're testing them, you're going to put them back into the f of x. You're going to tell me what inequality sign it is compared to 0. Now, since it's an inequality sign that is greater than 0, that doesn't match my sign where it says that it needs to be less than 0. Or sorry, it just needs to be a less than sign. So this one's greater than, so it's not the correct inequality, so that's not a part of my boundaries. So I go through test B. Again, you've got to go somewhere between -5 and -1/3 because that's my next boundary right over here. So I can plug in an easy one. Okay, I can easily plug in -1. Oops, this zero's in the wrong place. Sorry, guys. Right over there. So I can plug in that -1 because it's within my boundary points. So when I do that, I find it's -8. So when I compare that back to this function that we just talked about, it's just got to be right here. So since it is the same exact sign as my original problem, then yes, that's part of my boundary. Again, test C, meaning I'm testing this part of my boundary points now. So when I plug in that, plug in 0. Plug in the easiest point you possibly can. So when I plug that in, I find it just to be 5, and 5 is bigger than 0. So since I've got that inequality sign, that's not the one I'm looking for, it's a no. So the solution set is only from test B that we found, which was -5 to -1/3. Now you can go ahead and pause that just to get the information caught up. So just take a minute and go through the steps 1 through 5. Now here's why we are testing this. So again, we saw that -5 right here to infinity that was greater than 0. So that part's above the graph. Okay, -5 to -1/3, that part's below the graph. It's less than 0. So this was the part that was correct according to my boundary points. And then -1/3 to infinity, that was greater than. So when I'm going through and I'm finishing my number line, because you always have to finish it with your solution set, is you need to connect in between. You need to connect in between them because this is all parts of the graph that falls below. So it's just taking all of this from the parabola and showing it on your number line. It's taking all the numbers in between -5 and -1/3. So now go ahead and try the next problem on your own. Pause the video and go ahead and try it. Now here's our solution set. Now you can kind of go through and see, so I had to use a closed circle and an open circle this time. That open circle is in large part because of what the denominator can't be. Again, I have a denominator, I can't divide by 0, so you need to be cautious of that. But in the numerator, I can have certain numbers, so that's why I can have that included bracket because of the greater than or equal to sign. So you can go through and see some of my tests right here. And then last but not least, we want to see what's greater than or equal to 0, so you can see it right about here and up. That's all greater than 0, but then I've got that vertical asymptote in there, that's all below. So again, that's why it's only from here to my vertical asymptote. Those are the parts that are greater than 0. And again, it can be equal to. So this part B right here, this is how I'd write that solution set, and you can see how I wrote it right here on that 5. So -5/3, comma 3. And again, make sure to draw in the line between for all the points that are greater than or equal to 0. Okay, so now go ahead and try the last one and pause the video. And here's the solution set for this one. So I went ahead and simplified it to -x minus 3 over x squared minus 1 and set it equal to 0. So you'll see a lot of that work. Here's my work for all of it below. you can see I've got an A, B, C, and D for all my tests that I need to run. So negative infinity to -3, -3 to -1, -1 to 1, 1 to infinity. And again, I have a greater than sign. So I'm looking for everything that's above 0. So you can see on the graph from right here around that -4, so that negative infinity up until that -3 point, that part's above the graph. And then you can see that the parabola is above the graph, but then you can see this part over here with its asymptote is going to be below the x-axis for the graph. So if you have any questions, go ahead and go back through any part of the video and pause it wherever you need to. But that's the end of 2-7.